My name is David Thomas. I am with this.
Is that what DT stands
Call me DT. I'm just an account manager for F5 for the office. This ADSP. Been with the company for about 15 years. Prior to my role in this current role, I ran our channel for about 8 years for DoD. So I made many trips out here for this conference. I was at when it used to be at the Sheraton, YPP, and then it was over at Hawaiian Village. Now we're here at the Convention Center. One of the first tech talks we ever did for AFCEA, and that AFCEA ever did, was here, and it was an F5 tech talk. So we have a long heritage working with AFCEA. This year is a unique situation with the government shutdown. So you can see a benefit for life, but the message remains the same, right? And our goal is to bring tech out to you and to host a lot of these one-to-many sessions where we can help evangelize and bring our technology to you so we can learn about it. Today, we'll be talking about mission partner environments and a tetrographic solution and kind of empowering data and what you can do with some of F5 technology you're using it for both authentication and security. So we have some really smart people in the room with us today who will be leading the discussion. So Jeremiah Fowler, another longtime F5er, spent a lot of time in our professional services organization. So he's worked on a lot of these boxes that are deployed throughout the Department of Defense. And now he is covering Navy Marine Corps West for F5. Brandon Morgan is an engineer for F5, systems engineer working for DoD Systems Integrator. So we work with all the SIs out of Minnesota. And then Peter Scheffler, longtime F5er as well. He is a senior security architect, solutions architect. He does a lot of different things for F5, and he also helps a lot with these sorts of tech talks with DoD. We travel around to many different bases, bonus, and now we're out here in Hawaii. So this shirt that I gave you, this is the Tech on Tap shirt. So this is a series of training that we do for the DoD. And we host them at different breweries. So like in Columbus, Ohio, we'll do it at Brew Dome. In Oklahoma City, we'll host it at a Chicken and Pickle. It's like a top off the fishbowl. But we try to keep it fun, and we try to keep the vibe light and the messaging on target. So with that, enjoy, and we'll get you signed up for the CPEs as well. And if you have any questions, like Jeremiah said, just fire them away, right? This is a learning session, and we want you to get the most out of it. This way, Jeremiah, thanks.
No, thank you, Mr. Thomas. Today's unlocking data potential for the DoD today. We will wrap up with like an AI demo, and I think that's probably like the most exciting thing.
Come on, you're the most exciting thing in the room, baby.
This is fair. A little bit about me. I graduated with my associates in networking in 2002. I went back to school, graduated I think in 2007 for computer programming. I worked for Anheuser-Busch in the past. I worked for many trading companies. So like A.G. Edwards was a brokerage. And then I really got a job at Scottrade, which is an online trading platform. It got acquired by TD Ameritrade. Sad day. But that's really where I became like the F5 guy. So I've been doing this for like a long time. And then I'm like 13 and a half years here at F5. And 12 and a half, about 12 a solid 12, a little bit more than 12 years. That was PS, where primarily the Navy was my primary customer, Navy Marine Corps. I did some for DHS, DOJ, a lot for DISA, and we're going to kind of go into a couple of those. I'm not going to get like real deep unless like there's particular questions that you have on some of those items. I clearly have been a proud geek or nerd, whichever you think is the rest derogatory term. I like Star Wars, kaiju, anime, and samurai. For real. I am really, really into cars. I've modified every single one of them that I've owned. I'm the guy that's like, oh, why would you ruin a perfectly good daily driver? I'm that guy. I'm a huge fan of the SR-71. Anytime I'm near one, I will drive up to 3 hours out of my way to stop to see it. SR-71. This was in the Horse Museum in Stuttgart. If you're ever in Germany, if you're a car guy, you should absolutely go. They have like the race cars, like the actual race cars, and you can get like up the bumper shots where like you can see like the turbos hanging like right off the engine. Each one of the cars in the museum are ready to race. Like they have the individual throttle bodies or whatever have like what are those green balls that you hit with a mat or with tennis balls, like to keep stuff from getting into the throttle. And like everything is ready to go. I've done many marathons, so I've been running. My knees are not quite what they were, and I do martial arts. And sword cutting is like one of my favorite things. But yeah, so now you know what there is to know about me, and now we can kind of get into the solutions. And for the people just walking in, for the CPE,
Yeah.
we will get you the QR code. So cool. And if you have questions like about anything, just like try to keep it interactive and just feel free to just ask those questions. Oh no. Oh, I thought I ripped it all out. That's on me. That's on me. So who is F5? I think we're an industry leading app delivery and security for the globe. If you like go and you crawl the web, you're behind one of our products, either NGINX, which is a company that F5 acquired, or you're behind Big IP. Like if you were go and query any kind of web server. So if you like bank, you've been through us. If you have bought a plane ticket, you're going through us. If you played games on Xbox Live, you go through us. We're founded in '96, actually, as a game company. And one of the biggest investors was Bill Gates back in the day. This is the heyday of Windows. Today, we have about 6,500 people. We have over 23,000 customers around the globe, and we sell under different labels in like other countries. Patents. Last year, revenue was $2.8 billion, and just from security products alone was $1.1 billion last year. We're at over 80% of Fortune 500 companies, and like I was saying, more than we have about 50% market share. If you've been on anything on the internet, you go through us. Like it was saying, like banks, retail, all that stuff. As far as like partnering, so F5 doesn't have anything that's particularly non-RFC compliant. So if we make anything, it's to the RFC standard. So we don't really care like what your router, or your switch, or firewall is. As long as they're written to the RFC standard, we integrate with them. We've got some pretty cool things coming up with Red Hat. Nginx is FIPS certified if you're running on Red Hat that's running a FIPS compliant SSL stack. You can stand us up today as a container-based big IP in Google Cloud, Azure, and AWS. And we just had it for Nutanix because we're starting to get clients that want like that hyper-converged environment that's that you can just buy and it's like ready to go. And obviously AI, we have like a lot of stuff going on with NVIDIA. I don't know. I wasn't really going to get into that, but we have codified TMOS to run on an ARM processor. So like if you have an AI workload, you can stand up big IP in the TPU/DPU for AI workload routing. So you don't have to like burn CPU cycles to do that. Right? So, well, obviously we love working with Splunk, and if we'll kind of talk a little bit about visibility, but the challenges, as I have viewed them, and I've heard from our clients in Indo-Pacom, are it's a huge area, right? Possibility of being disconnected. So you would hope that you have like a radio signal or a satellite signal, but that's not always the case. As of today, there's no single source for all the users, which is very much a similar problem with the DISA REL-A had. They call it mission partner environment, and that's one of the use cases we're absolutely going to get into. The other problem with being out at sea is lower bandwidth. It's like you don't have a 1 gig pipe, that the ship is carrying around with it, right? And so I did some research, and there are a couple items that the War College sees as being problematic for the Indo-Pacific, and they call it the triad, and that's the multi-domain contested, and that's land, maritime, air, space, and cyberspace. As far as that is concerned, F5, as far as sending data, as long as you have layers 1 and layer 2, we can take care of the rest of it.
Yeah, actually, maybe, do you mind if I still?
Yeah.
Okay. So something interesting that I just read, sorry, I'm getting pulled from stuff. This was an article, last week, I think it was. Last week. I'll dig it up. But when we sort of talk about the challenges in Indo-Pacom, it's one of the things that is near and dear to my heart is crypto, and ensuring things are properly encrypted from point to point. And so when we think about traffic flowing across layer 1 and layer 2, we kind of think of it's a wire, it's gonna be a wire, right? Well, in this theater, wires get very, very long, and it's very hard to manage that, right? So one of the things that you might turn to rely on might be satellite-based communication, like a LEO environment, low Earth orbit environment. And there was a researcher in, I want to say, San Diego State, but the article might say it's another California university. But they did a poll of a bunch of endpoints that were out there, and these were unencrypted conversations. And they were satellite-based communication. So these satellites were streaming down data, and it was unencrypted. So you don't have control over layer one in that environment, because anybody with the article was basically a $700 a purchase gets you connected to these endpoints. U.S. Navy was one of the endpoints. T-Mobile was one of the endpoints. So your T-Mobile phone, if it was a T-Mobile connection, they were using satellite for sparse and different locations. Walmart was another one. There was banks that had ATM conversations that were, again, in sparse and very remote areas where they didn't have a layer one connection. They don't have a fiber connection. They don't have a cable running through there. They were relying on these satellites. And if you think about it, this is a decision that was made because every ounce that you're going to fly into space is very expensive. So by reducing the need and saying, well, we won't put crypto in with boxes and we're going to send them up, and we'll do software encryption. Well, somebody thought somebody else had taken care of the problem, right? So I think as we look at challenges in the Indo-Pacific, it just resonates, like that story, which is literally 2 weeks old. Like, and they held the article coming out. It even says because they wanted to make sure that the Navy knew and Walmart knew and T-Mobile knew before they released the article. So it happens. And one of the things really, an F5 solution could be is to give you. We're not going to give you, Suite B or encryption that maybe a certain agency in a fort in Baltimore is interested in, or Maryland's interested in, but we can give you encryption that at least gets you through and it stops just people from sniffing it, because these are completely unencrypted travel. So think about your ATM when you're sitting on a side road in the middle of, I don't know, wherever it was. They didn't say where it was. I don't know, pick a place, Montana, and filling up with gas, and you're paying, and you're thinking you're tapping, and everything's secure. But turns out it wasn't. These were unencrypted conversations. Sorry to interrupt.
That would make me physically ill. So, I mean, with like a financial background, like you can't have anything on the wire that's unencrypted. I mean, that's the way it is.
Yeah. Tell that to the bank that was in that article. I don't think they named the bank, but they might. I'm going to pull the article up.
One of the other triad is joint logistics over the shore. And that is, for secure communications between branches. So Army needs to have information that Navy has, that Marines may also need, Air Force. And if obviously you don't want anything like that that's forward deployed in like a contested area to be clear text. You want that to be encrypted.
Okay, I posted that article yesterday. Well, there you go. That's literally this week.
And then the last part of the triad is the urban littoral logistics, and that's the Pacific Rim. It's like densely populated urban areas based around ports. And a lot of that gets kind of into like the physical side of things, and that's not really what F5 does, so we're not going to talk about that. I just thought it was interesting because I enjoy reading about current things and history because that's what makes humanity what we are, right? Being able to know what happened the day before. What we're going to cover, a light touch on zero trust architecture. Some people call it ZTAA. F5 and a couple other companies tend to refer to it as like zero trust application architecture. Because, I mean, what's in front of us and what's behind of us doesn't really matter anymore. Everything is kind of like the edge at this point, especially if you have like, you have your data center with like a firewall. So you're going to have the same matching rule in AWS or GCP? Probably not. So wherever wherever your data in your app are, that is the edge. The other thing we're going to touch on is attribute-based access control. That's being able to make a decision for, oh, you have access to this app and this app, but you don't have access to these certain URIs that are on that same app, based upon like something from your CAC or maybe something that's like a SAML attribute. The dynamic user control is something that's really slick. This is SAML based, and we spend like a little bit of time on this because I don't know what everybody's familiarity with SAML is. And then obviously being able to remain lethal and operational in a DDIL environment, which is disrupted, degraded, intermittent, and low bandwidth. And then again, we'll wrap up with the live demo of the AI and API ready workflows. We've got kind of a cool couple things as far as like API readiness, which we're not going to do, but we're focused on AI today because it's brand new lab, very slick. And then feel free for questions. So I hate death by PowerPoint, but I know that I had like a 2-hour block and I had to keep you guys going. So, but yeah, zero trust. And I'm not going to read this to you because I feel like most people have the reading ability to read this, but it's from John Sherman, the DoD CIO. So zero trust is, I can't believe it's like that's not the way that everything was set up anyway. I've been in like some skiffs where they were transmitting stuff clear text from like TSSCI, no foreign web pages, because the server had a SSL bug. And I was just like, okay, it makes perfect sense. So these are the 7 pillars, right? User, device, app, data, network environment, automation, and visibility. F5 doesn't play in every one of these. With the purchase of our AI integrations, I feel like that there's that once it's like releasable with a SKU, I think that like the data labeling and tagging and the DLP and the like data governance as far as AI is concerned, I think we will probably play into those. And none of these does F5 like cover everything, so we're not trying to like be the hammer that fixes everything. But there's like very specific things that we kind of like play along with your other vendors that you probably already have in the environment. But for user, we talk about ABAC for least privilege. You can do like time-based for conditional user access. MFA, our identity aware proxy integration with MFA for like if you have Duo or like a GTP OT, the Google OTP, we integrate with that. If you're doing like RSA, those things are what the identity aware proxy does well. We have we do federation with like OAuth. So if you're using like OAuth, we integrate with that. SAML, we integrate with that. For device, we can query for the identity aware proxy based upon like, is your device up to date with your commands requirements, like antivirus, you have the highest patching level on your OS. And then we offer a VPN and a per app VPN. For application workload, we can keep track of applications. It's not really the application inventory is like partially. I kind of waffled on including that one or not. Software risk management, we do have some API crawlers that will like point out issues that your APIs have, and we do have a web application firewall that can make recommendations, if assuming you're running it, on how best to secure that application. Like if it's season tax, is this how the app was written, or is this someone actually trying to exfiltrate data from it? The networking, Obviously, we do segmentation. So if you have like multiple domains and you're using VRFs, virtual route forwarding, we can align a similar technology to that. Uh, Automation orchestration. So everything that you can do in the GUI or the command line, you can do with like a YAML play file um, to the box. So you can stand up like the Nginx or Big IP, all that via the REST API. And then visibility analytics, we have a great break and inspect item that was kind of written for the NIAP protection profile, which requires no SSL all the way through to the backend application, but you actually have to break at a device and then have it inspected before you're allowing it to the backend server. And all the items that are in that are what's in the product today, and it's been available and it's really mature. I've been putting it in since version 12. We're on like version 17 and a half now. And I think it's a really solid product. This is a high end user. If you operate on a DoD environment and you web surf, you're going through it. You just don't know it's there. So, and then event logging, which kind of plays along with that analytics and visibility. Who went where, when, what were they trying to do, those type of things. So like we've talked about the ABAC use case, and this particular use case was for Relay for the Five Eyes mission partner. And the what's up is you have, Australia, you have New Zealand, you have Canada, UK, and they need access to something that's within the CIFR environment of America, or maybe we need something from them. Legacy was had been put in like a long time ago, and those boxes were way past being valid. They weren't even supposed to be on a DoD network. And based upon country of origin, so we can do it based on your source IP, or based upon items like if you had on your CAC it said like country of origin, we can trigger off of that. So we would tag it, we would break and inspect, and then allow you through to the backend application. Another really cool.
Relying on the claim that comes through, maybe it's the co-op system responsible for figuring out who you are and what your activists are.
Yes. So we're going to get into that. That is coming. So there was another use case where there's like another APM or some other server on the far side, right? So don't consider on-prem, but think like a cloud provider where the identity aware proxy is in between the flow. Let's say that you had another box that needed client-server authentication. We can forge a certificate with the same attributes that we just had from our trusted subordinate CA and send the client certificate when the box in AWS requests a client certificate for their next step of authentication. That was a solid, like that was a rock block of work that we did. And as soon as we would fix what's up?
Was it custom or like never important seeing the thing along the road?
It was a very big command within the DoD that requested that. And it's in use today. It replaced the legacy system, something that other companies had tried and it didn't work out. So, and that's kind of what this one is about. I refer to it as forward proxy modernization because everybody's like, oh, can you replace Blue Coat? Well, I mean, we're not Blue Coat, so we're not replacing it. But we can kind of meet those requirements with TMOS. So, like we were talking, like before I got here, the mission partner clients needed access to U.S. resources for like information sharing and vice versa. So the same way that we stood something up in the U.S., we stood up equivalent flows in Canada and equivalent flows in UK, right? So same product, just in a different situated in a different setup, in inverse. So external users may or may not use the same authentication. So there was like one country that doesn't have PKI. So we had to offer them a username and password, which I thought was wild. But that's not really my problem. That's their problem. And there was the need to break and inspect all traffic coming into and out of the U.S. enclaves. And that's where SSLO kind of gets into, which is my favorite product that we have, bar none. And just so you know, I don't think I included this in anything, but F5 released PQC with the Kyber crystal key exchange method earlier this year, and it's on both sides. So, which was the closest to an agreed upon standard for PQC today. Correct? Yep. So, if you want post-quantum cryptography, we already got you.
And they're mandating us.
That's right.
By 2027, I believe a lot of USB. So we're seeing a lot of customers on this, this and gravitate towards the new log series of mine because it's you can see that.
And then SGen will be hardware accelerated.
Yes.
And so R series is the current set today, and the throughput is like wild.
Our series is the appliance.
That's correct.
It's a series.
Because right, we have hardware and we have you can run anything that we offer as far as Big IP is concerned on our hardware, but you can also run it as software. If you have your own, like Red Hat or VMware or whatever, or you can run AWS if you want to. An ability to forge client certificates. Shoving this in a forward proxy solution took imagination, but because all of our products are highly programmable, you can do those things. They're highly programmable on the data plane, and it's in service today. And forward proxy would allow or deny based on the host URL, IP, and URI. So you can be like, oh, the source IP is this, give them this rule set. And if the host is this, yeah, allow them. But if the URI is this, then deny them. So we were able to meet the same kind of like requirements that Blue Coat had put in.
The policy definition in Canada language, or is it listening to your
It's
So the policy definition for,
you allow deny stuff.
so you want to go back?
yeah, the previous for.
So I was talking about the layering, being able to allow based on source IP, host URL, or URI.
Yeah, it's not natural language. It is a configuration, right? So you say you define your services, and then you define a service chain, and then you define the criteria that enters into that service chain. So the beauty is once you define a service, your next gen firewall, your IPS, your store only device or whatever, you define that once, and then you can say for this traffic coming from the user network going out to a financial organization, we don't want to decrypt it. but we want to send it through our devices for best effort, or want to send it to the store only device and store it, even if it's encrypted. But anything else is going to be decrypted and goes through next gen firewall, the IPS, and the store only device. And if it passes all three of those, then it gets sent out and re-encrypted. So you don't need to set up a route on your devices. It's defined by the service chain. It loops the traffic through it independently.
If you know how to VLAN tag, okay, so
For the guy who's configuration,
yes,
that's what you're asking. When we're talking about configuration, we need to get through, there's a guide to configuration for building the house, and then specifying the name of that.
Yeah, like, I think I'm fairly adept at a big IP, and I could probably set up a single service entry and route traffic in and out of there. You could give me 2 devices, and I'd be like, okay, give me a couple days and I'll get it done. You give me 3, and I'm gonna flip the desk and walk out. Because now we have to make all these weird decisions and how we route traffic in and out of them, and it becomes very complex. But I had one customer, very large financial company, and they wanted to start moving. They had been using our SSLO for years, let's say 5 years, and then they wanted to inspect their OneDrive traffic, and so they were looking at probably another 10 gigs of 10 gigabits per second of traffic just for the OneDrive. Which is a big financial organization, and they came to us and said, "Well, how do we re-architect this?" And I said, "What do you mean re-architect?" And I said, "Well, we want to put this traffic in here, and we got to figure out how we're going to route the traffic in, and we're going to route the devices through." And I said, "You just create a new service chain. Like, the new service entry is if it's coming from or going to OneDrive, which devices you want to go through. It needs to go through these 3 devices. Okay, there's your service chain." So it was a 5-minute conversation. They didn't need to re-architect anything. Just deployed it, and that was it.
so if you're interested, I have the tech guide that we give the techs when they go out. Like, I'm the guy that wrote it. Or if you want, catch me later this week, and I can spin up a lab, and I can show you what it looks like in the GUI.
You just said catch outside.
How about that? But catch me, like, not in this room, outside, and we can. I'd be more than happy to show you what it looks like. But yeah,
The lab thing is interesting. Here, you can spin up. We can spin up UDF environments, customized for your use cases. But you do have some specific use cases and you'd like to run through and turn some knobs. But that's why doing that virtually and set it up like 10 minutes, right? It doesn't take much.
no, it's slick. So when I worked at the bank, we had the very classic core ag access network, and so we had 40 gigs between core to ag and 40 gigs from ag to access, and we had it times 2 because it's a network. That's the way it's supposed to be. But buying inspection devices for every 4 fibers is like prohibitively expensive to do that for the A side and the B side, right? So everything would just be on the A side. In the classic big IP, I created data group route domains, which is like a VRF, to send traffic through an inspection device that hung right off of the ag router, so we can inspect the traffic if it was on the A side or the B side. And that's what SSL will let you do. So you can put it up at the very top, or you can put it kind of down lower, closer to the data. Yeah. And then obviously we were talking about controlling client access. via the Ford proxy. So we have an identity-aware proxy where you can do decisions based off IP address or credentials. And then we can do client auth inline via like NCLM, Kerberos, or like if you really wanted to hack a smart card authentication, you can use a captive portal for MFA enablement. Obviously, SSLO is there to meet the break and inspect compliance and user tracking. Because to me, knowing who did what when are kind of like requirements for forensics. Right? So dynamic user control. This is a use case from CENTCOM. And the same thing, MPE, other countries needed access to internal U.S. resources, which is controlled by the country TetraCap. And we're going to kind of get into what that is, security clearance, and need to know. Here's the problem. External users maintain control over their auth method in their country's internal environment. So we don't have an IDP for them. No local admin account creation or maintenance. Everything had to be done automated. And the internal LDAP directory and Active Directory and SharePoint auth either utilizes NTLM v2 or Kerberos. Like those are the SSO methods that were in the environment that they needed access to. So classically, this is a network-centric approach, right? We talked about this earlier. Network, client to a firewall, to the web server, and then to the database. But if you have a data-centric, where you have essentially one data center, right? And you have Canada, you have information of like France and Canada, or Canada, France, and Belgium. We would refer to that as like a data-centric approach. So you need access to something based upon the data. You don't want to build a data center for that because that can become expensive, right? Right? Because you don't want to do it over and over and over again. You just want to do it once. Oh my gosh. So some of these slides I didn't make because I would not have done that many animations. I can promise you that.
You gotta use your moves.
Yeah, I probably should have. Always double tap. Always double tap. So this is we had like a legacy one. I thought it was cool. My account manager thought that it wasn't colorful or happy, so we did it another way. And then so we talked about the SAML, right? So we're gonna do the attributes that we're talking about here are clearance level, common name, country, display name, given name, UID, so social number, and their user ID. So I believe that Indo-Pacom is going to have the same use case as CENTCOM had, right? Because they're the same thing. External users, they still want to maintain control over their auth method in their country, right? We don't want to have local admins, and our internal LDAP could do NTLM v2 or Kerberos, or it could do the client certificate constrained delegation. Oh, I thought I saw something. I've had eye surgeries, so like if my peripheral is not great, I thought somebody's hand went up. Has anyone done SAML Federation? All right. Okay. So that's cool. I promise no quiz, so I'm not going to quiz you on it. Naval Identity Services uses ping for SAML Federation. So Navy's moving to this like unified platform where everything is going to be SAML, where ping does the smart card prompt and everything else. And that's where we're going. But from a high level, this is the user flow. So client shows up to the SAML SP service provider. So the client asks, we know who the IDP is, and we do a redirect to the identity provider. So then the client goes to the identity provider. This would be the country's identity provider, or the same thing for NIS. It would point you to ping where you CAC in, and then they send the assertion back to the client, and then the client includes that assertion when they show back up. So then the F5 is like, oh, bet, fam, and I'm going to let you in because you have shown up with a valid assertion. And this one has like a lot of animation because I knew that I had to consume some time. But I've almost done an hour. So like this one has animation, but I didn't really remove any from this because I think that it's kind of cool. But again, this isn't sitcom today. I think that Indo-Pacom users could leverage this same working solution as soon as they're ready. So in this case, the F5 is the SAML service provider. So here's our big IP. And we have a trust relationship between us and, let's say, I don't know, Japan, right? They're kind of like a mission partner. So Timmy, logs in and who requests the SharePoint server that's behind the big IP, right? SharePoint me or SharePoint mpe.command.mil. Right? Fair? So the big IP redirects the client to the identity provider. And he's like, he CACs in, he's good. Or maybe it's username, password. We really don't care because we're not controlling that. The country is controlling that. So like, cool, here's my assertion. And the client is redirected back to us. So again, these are those attributes that we talked about a couple minutes ago. And then country of affiliation, Canada, okay? And then the tetragraph, and it's like, oh, maybe they're Canada. Maybe they include all these countries, right? But you're going to have the country of affiliation, and then this would be like what you have access to, right? This is your ABAC portion of it. F5's like bet, and it sends it on its way. So traditionally, you would have to do this in a way that you would have to create the client in your Active Directory. SimCom's like, that's too much work. We're not going to do that. So F5 created an iRule, and this is what legacy iRules are built on this command language called Tickle tool command language. It's highly modified by F5 so you don't have to do everything. Like you can say access policy, agent ID, and it will do an add. So what it does is it grabs from the SAML assertion all these items, and all these variables are set, and then using iRules LX, the initial, which is a Node.js container that runs in Big IP, we would play that and create the user in the local Active Directory. Today, it is put in as a container that does the same logic. So the F5 just does an HTTP REST call to this container, this Docker container, that generates a user and a password. And in the internal Active Directory, and these users are cleaned up after X amount of time. I think it's like 24 hours or something like that. If anything's different, if anything's changed, just cut it out. So these users get a Active Directory account created. The client never sees that account, and the client never sees that password. But if your SharePoint server is using NTLM, and it's like, oh, can you log in for me via SSO? The F5 is an identity-aware proxy federated via SAML, just replies back with the NTLM v2 credentials. Or if you're doing what I love, which is Kerberos, we just cut your Kerberos ticket with S4U2 proxy, and you get logged in. And your update and your login timer for Active Directory gets reset. There's been many a times where that was the fix for users that never came into the office. So, yeah. There's does that make sense? I think the animations are like rad. That's the only reason I left them in. But I realized that I ran you through all this, and I should have just been like double tapping the whole time. So that's kind of on me. So does that make sense?
So does your DIP member and if you're doing the real
So that's the best part, is this runs and it generates a dynamic password every time the client shows up. So the password is recreated via the container, and it's updated to Active Directory.
each time that we could, if I'm logging in 20 times a day, I can do that. What's your mind?
You still have the same user associated with it because you want that traceability.
But it would just update the
The
password.
password would
So is that why we would be so on is that why that would be trustworthy?
Yep.
If we still have to allow them to go through the data license, then they'll go through the
Right. So let's say that Micronesia just became a mission partner, and this is on island, and they're like, oh, just go to SharePoint, but we didn't have a trust relationship. When they hit us, we're not going to know how to direct them to the to Micronesia's IDP. Does that make sense? So you have to kind of have that binding first. So we create an XML payload that's like, oh, my name's SharePoint.navy.mil, SP.SharePoint, whatever. That's a service provider. So, or maybe it's a web top, or maybe it's a VDI. Maybe this is running in U.S. Forces Japan, and U.S. Forces Japan has that SP. The IDP would kick out its own XML, and we do an exchange. Generally, it's like sent, or maybe the guy who has command of the big IP is like, oh, we're bringing this new IDP on, just add him. And as soon as that is done, because the IDP wouldn't know the service provider's host or URI. And I think that there's a picture on that, but this is essentially what the web top looks like in real life. I mean, not now. Now it has many more apps, but you get the idea. And again, they offered like VMware View, which is actually like starting to become. It's starting to get traction again, which is wild. But
This slide, there's also a requirement to have your lines act as
yeah. So
that relationship also has to be set up. Right?
yeah, yep.
So internally, I have to set up my device as constant bandwidth.
So what we do is we do Kerberos protocol transition, which is including the Kerberos ticket in HTTP. So what you do is you would just create a service account for the F5. So it'd be like F5 dot, yeah, right, at the realm, at that, where the application's at. And then you just add those applications as delegation. If you have multiple realms, if they have a full two-way transit of trust, you can just make it just for the app. You're probably not going to be doing that though, because I don't. So this is like old school tribal knowledge that not everybody knows. The F5, when it gets a Kerberos ticket, if you have multiple realms, it gets like confused and it doesn't know which one. And this is an old bug. And at this point, since the big IP runs in a container, if I was going to do multiple realms that had like no shared apps between them and there was no trust, I would just stand up another containerized big IP and I would just do the service account for that on that other big IP. And you don't like, I would never have ended up down this rabbit hole, but in this one client, they had like what they called service area A, which is like a dev zone. And everything was the same in prod, but everything in the service A was called A dot. And so we were doing Kerberos ticket, and it was fine for prod, and then it would be fine for A. But if someone tried to go back into prod, like not associated with service A, it was sending the A Kerberos ticket. It didn't like, and I had thought at this point, because this is a very old bug, it had been resolved. It had not, and this is like 8 years ago, and this is before everybody's running VEs everywhere. It may have been fixed. I haven't went down that hole, down the rabbit hole recently, but does that kind of help?
Yeah.
Now, NTLM, you just join the big IP to your NTLM environment. As long as you have a service account, that's it. So this is what the identity aware proxy flow looks like. So the client gets the DoD notice. All your base all belong to us. And then based upon the client subnet match. So if it's internal, we do the ephemeral auth variable assign. We query AD with that username and the password that we just made. We play it to the TechNet. We do the mapping, and then we assign it to the service SharePoint pool. So it's like Kerberos or NTLM. And that's up to the command, right? So I just like Kerberos because it's kind of like trusted across the board. That's correct. So this is what it looks like in the GUI today. And it's looked like this for a very long time. And it's like, you can have like just one thing, or you can like collapse this into a macro. You can make it super cool. And I have so many different things like this in UDF. If you ever wanted to go like view it, I'd be more than happy to kind of show you how kind of flexible it is. And this is a session policy. You also have the same flow for per request. So if you needed the ability to like step up authenticate someone, so like, okay, you get access to all of these things, but if you're trying to get to this URI, I'm going to prompt you for your admin token, or maybe you have a OTP or whatever. So you can do that, and that's a per request. And the per request fires every time a get or a post or a modifier or put or whatever shows up to the big IP after you have an approved session policy. And then from the external, it knows who you are, and it would redirect you to SAML. And when you get a valid SAML return, it creates that ephemeral auth again, assigns it to the pool, because the mapping happens within this ephemeral auth, and then route domain and stat selection, and then whatever else. And you just have one of these for every country. And to me, if it weren't for like this demo, I would create each of these as a macro. So it would be like a very cute, short policy. It'd be super slick. But yeah, I know this is a lot, and I'm kind of like dumping a lot on you. So, but as far as like what we pull out of that same old assertion, like this is just this is a view of what that I rule looks like, and then it plays it to update Active Directory, and then the AD has like a thing that goes through and cleans everything up after 24 or at the end of the day or whatever.
So the irony was just customized, like you said, programmable, right?
Yep.
Script can be added. I mean, that's really the differentiator of the thing. I rules.
Yep.
So, I mean, we don't have to dive into that. So an I rule, I don't know if it's like clarify.
This is the programmability of the data plane. And we're getting ready to introduce WebAssembly. F5 has acquired companies. Everyone who had anything to do with WebAssembly, the creation, the maintenance, the sustainment of it, now works for F5. And it runs, Tickle is fast. WebAssembly is like, I think it's like 80% faster than tool command language. It screams. And so it's any package or whatever that is written in WebAssembly, you're gonna be able to just run it inside the container on Big IP. So this is the way it's been since I've been an F5 guy. And we have natural language AI for creating these things where you can like hop out on our distributed cloud platform, be like, I need an I rule that does pool selection based on URI. You give it the URIs and the AI will generate that code. And none of this existed like when I was coming up in the world. So it's a super cool time to be into F5. And then this again is just kind of like wrapping it up for the country dynamic user creation. It's Big IP. It's a ephemeral auth Docker container. If you don't have a Docker environment, it can run on the Big IP and that Node.js container. And then it would just update Active Directory. And then we just do SSO to the SharePoint server. So you don't have to maintain users. You just do it and it's good to go. Is that kind of cool? Because I remember making like shadow accounts like for the Marine Corps. Man, it's nightmare fuel. And then this is like, imagine having an Active Directory and you basically copy everything to another Active Directory. And this is everything we just covered, but it's just wrapped up in one slide. And then this, I think, yeah.
That whole process is to grant country X access to your home server.
Yep. Or whatever. So, but the beauty of it is you don't have to maintain users. You don't have to set up users. You just have to have a trust relationship between the Big IP and country or company X.
Whatever that second part is.
You got it. And then based upon these things, these are the items that are added to Active Directory to that dynamic account. And then we just set the password. So like if they logged off because of launch and they came back, we know the account's there. And it just updates the password. Because we have this other product I'm not going to get into because it's its own thing. But we have the ephemeral password creation is like pretty paramount for SSO. Yeah, it's this other thing. It's to enable CAC enable or whatever anything behind the F5 that is like SSH based, or you can even do SSH key authentication like keygen, but for like username and password, and it dynamically creates a password, and your Cisco router or whatever asks ICE, which is pointing to the F5 as the LDAP, and on a bind request, as long as it's our OTP password, then we send an auth signal. And if it's not an auth, if it's something else, we just allow it to proxy through. There's a lot there for PUA, so just from like a high level, that's
interesting thing on that, Jeremiah. There was a lot of these things that he's talking about and that have become productized at F5 are all born out of the DoD. We talked about SSL. Well, we're not a stuff. They said we need a range flex solution. SSL before that they're already doing SSL. They make regular orchestration. Privileged user access. They got to get their ports to start to get rid of or so as he was talking about. And now in the backend product, there's several others as well. So, you know,
client certificate constrained delegation.
Yeah, exactly. Right.
Kerberos SSO
So
out of the Air Force.
So like people like Jeremiah and Chet, Brandon, and Kari and I, you listen to the concern and hear kind of what the challenges are that you all are having, and then kind of customize that, program it, right, build it, and then F5 picks it up, kind of give it a stamp of approval, make it a supported product, right? So you call them, they support on it, and then the rest of the company starts to catch on and Bank of America is like, I need this too, right?
And that's how it goes.
Most of these things are geared for.
Yeah. This one, was being able to operate in a disconnected environment, in a DDIL environment. Some of the use cases, and this is from PEO SBA. The use cases were in a DDIL environment. The expectations is decentralized command and control, and really, what the goal is, you create the commander's intent, and then how it's executed. If they know it's a contested area and it's not great communication, they don't really care how it gets done. And obviously being able to have resilient mission data. And for me, one of the things that we have been told uses, the warfighter need to know the last coordinates of a mission while the information is still secured, by identity or proxy to prevent information falling into someone who happens to, get access to data in whatever way. So obviously you need technological resilience and redundancy, multi-path diversity. So is it satellite, is it radio, whatever. That's why I said if you have like layer 1 and layer 2, we're good to go. We'll have a self IP on the F5. Whatever your other path is has an IP, and we just have a default route, and we just route to whoever route. And then edge computing. So being able to process data at the tactical edge. I don't know if anybody's seen the kits that they have. They're like 40 pounds, and it's like a carbon fiber case, and it's like everything is in this case. You just spool up your big IP or Nginx in that case, and you get all the feature set that you're after. Pool was actually the first kind of tactical edge use case back in the day. And then these are some of the other things I thought they were interesting in DDIL. But that's kind of who I am. I see a rabbit, and sometimes I just start chasing it. So I just thought that this was like a break from technology for a minute. You know, train train for the contest environment, right? Embrace failures, use to learn how to operate and restore connectivity. And how F5 could kind of play into that would be enable the utilization of playbooks for automatic rebuild of equipment. And we kind of do that today. But for so this is what the PEO SDA use case is. It was for PACLAN. And so these are your guys at the edge. So, the red environment, they only have drones, laptops, device, and then you have your warfighter. Blue includes like radio towers, and then the green has your IoT, drones, and everything else. And these are allowed to operate on the radio towers. But you have your big IP that does your web application firewall, your proxy, your identity aware proxy. We could do load balancing or traffic routing based on like host or URI. DNS. So if all your apps are written for DNS, which I hope that they are, the F5 can answer that. So even if you're disconnected, we can still allow your apps to run locally, device management and DDoS. And then after them, for like east and west. So if you have you run our other great product with Nginx microservices, and then you run Nginx for your Kubernetes data fabric. And each one of those, you can have like a blanket WAF here, and then as you get closer and closer to the app, you have like a more defined application-based web application firewall. But basically, these guys would still be able to connect to any apps running inside that 40-pound rig that the F5 can route traffic to. And then as soon as like connectivity is restored, you start updating the local files. I mean, obviously this would be like an app-based thing. The F5 is not going to do that. And there's kind of like a use case to be said. Like, let's say you have that tetrograph at the edge, and let's say your connectivity goes down. Well, the F5, remember on that the visual policy editor, you could have like in DDIL environment, and you could have like a local login for those guys at the edge, based upon maybe just on the CAC. Like let's say they need to get in and get like the last known good coordinates or something, and SAML is down. We could do a fallback to a smart card option, and then make decisions based off of that, the attributes on that CAC. So that's kind of what I had, and it's like just about the amount of time that I had expected.
Prioritize network traffic to specific applications.
Absolutely.
Terms and things, all prices.
With iRules, yeah, and we have another under the hood. It's called iCall, and that allows you to make changes to like would your goal be like QoS mapping?
Yeah, like when you show with users at the edge,
Mhm.
and then multiple paths on your network.
Oh, so maybe you had something here trying to call out.
Go out to where you're now, and you had a 1 gig, now you're down to a speed. Very small.
Right.
Flash. You just want critical message traffic, like bytes. Not
Right.
versus not like video feed.
So you can monitor your next hop in this thing called a pool.
Yeah.
And as that pool goes down, you can have like health checks, and you can have a unique health check for like each node. And as nodes go down, So like, let's say you were just on the satellite.
Like, it's got some dynamic routing built in, right?
Yes. I would call it routing, but traffic selection. So what you do, you say, oh, well, anything that's in the cluster trying to call out, if this is the only one still up, that would be the only traffic that we allow out. So you can apply like an ACL to that. Or you could even have an I rule on your forwarding VIF. It'd say, if this, then this. If this, then, or, if else. And I rules are very flexible in that way. And you can just drop the traffic and say, and each time that request goes out, the F5 would just shunt the traffic until, but if you're like, oh, coordinate update, and we have a flow, then we allow it. You basically say return, and that allows the forwarding VIP to send the traffic outbound. Does that make sense? You good with that? And so these are like how ideas are like, this is how like stuff gets created. I'm not like hyper creative on my own, but when a client has a request, they're like, oh yeah, we could do that. It's just, you say, if this, then this. But yeah. And these were the, basically the question you asked, because I was like on the plane and I was like, this is how I'd approach it. And obviously a lot of this has to do with introduction of edge computing at the tactical edge, right? And visibility for data being sent and received, because not only do we want to share the data, but you want to have like a forensic trail.
Yeah, and you want to be able to have that trail and survive detailed situations too, right? So some of the things we've been talking to the different DoD entities really is, like you said, in a crisis event, we have to assume we will be detailed. Like we have to assume that the warfighter at the edge is going to be making the decisions that they need to make without a broader context. And so we need to be able to provide them the best information as close to them as possible, but not forego the security requirements, because that device could be compromised, the information on that can be compromised, so that we want to make sure that all those components are properly hemmed in and still protected, and audited too. And also, as command and control changes and the fluid things happen that happen in a crisis, we need to be able to change and morph to that too. So
So the primary focus of this access unit.
So again, we're making a traffic steering decision, and paramount to that traffic steering decision is the identity of the device, of the user, and the data. So it's always going to be involved in that process. So yeah. But it's no less important than steering to the right device, giving the right answer.
Yeah.
Yeah.
Because it collapse segment of networks into one network.
Yep.
Build it all.
Neat, huh? And then this was like, I think I'm getting right up to the edge of the demo.
My demo is the ones that need to be. I mean, I can do it for 2 hours. I can do it for 30 seconds.
So this was brought to us by NTT Docomo, which is like a provider.
So yeah, well, NTT is the telecom, but I mean, it's a huge umbrella company. So it's more like IBM than it's like telecom.
But basically, I'm like Edge AI, right? And so for like traffic steering and all that, instead of running it in the CPU, F5 was factored to run in the ARM chipset. So you can make traffic steering on big IP in Kubernetes. It's at the DPU. And so these are container native functions like firewall, DDoS, carrier grade net, DNS, and we can do AI based routing. So potentially you may have like multiple
Well, yeah, not AI based routing, but
routing
AI,
to
routing AI traffic. So,
yeah, routing AI traffic. My bad.
Which is what we want to do, right?
yeah,
That's right.
we just moved it in the AI space. There are several tiers that you have to worry about. Where you got to worry about the training, you got to build the data, and there's a lot of movement of that data during the training process. So then, the beauty that Amazon did several years ago is they came up with S3, right? So that is just an HTTP storage protocol. What's Big IP been doing for the last 20 years? We're moving HTTP around, so we can optimize that. So one of our large OEMs, computer OEMs, needs to move 400 gigabits of data back and forth across their environment as they're doing this training. So we built a optimization of the S3 protocol, and so now in Big IP 21 that's coming out in a couple of weeks, you'll actually have in your dropdown a TCP profile that is an HTTP profile that is optimized for S3. So there's TCP and an HTTP profile that now optimizes for S3. So now you can optimize that traffic and get the best flow you possibly can. So we were literally saturating the 400 gig NICs on a Dulles chassis to move the data around. So you've moved all this data around, you've built your model. Now you need to optimize the inference. So the other side of it. So you've trained it, now you've got a model, now you need to go do something with it, and you're going to have inference happening at that level. That also needs to move back and move in one direction. So you typically are going to, when you are doing RAG, which is like the information that you want to give it around it. So it gives it context or whatever, right? So and you need to move that closer to the GPUs for it to see that. So you need to move that from tier 1 storage, which is super fast already, but you need to move it to like M2 disks that are really, really fast. You're going to move that to tier 0 storage. So again, it's all S3 data. So we can pick that up and move that in. And then once you start doing the inference, the GPUs start to need to be used. So if we look at sort of the discussion here, you've got a DPU here and you've got a DPU here on these two chips. Well, when you're not optimizing the traffic to those DPUs, they're crazy expensive, right? So you maybe got an H200, costs $40 million or whatever that price is. It's 200 GPUs in it, right? And you want to make sure that you're properly utilizing all of those 200 GPUs. You don't overloading 3 of them and have 197 waiting for nothing, right? So you want to be able to move that traffic across. So what we can do is with our Big IP for Kubernetes, right? So right in the Kubernetes environment, we can start to flow that across all of those. We can do that with ECMP. We can do that with DNS. We can also do that with just basic load balancing algorithms and move that across all those. We also get the data back from the DPUs to say, how busy are you? And so we can make a decision, that one's too busy, or the latency on that one's been too high, so it must be doing some crazy inference that's causing it to respond slowly. We're going to go to another one. So we can optimize that. And so I'm working with a university right now where they have 3 superpods. So 3 of these things, 200 DPUs across their environment, they have to make sure that they're optimizing it. The other thing we're doing, so we had a company in France where they had a single superpod, but then they had a bunch of other pods that they wanted to use as well. And this university is also doing that too. So they actually have these superpods, but the superpods, all of them don't have DPUs. They have Kubernetes environments that won't have DPUs. So they want to optimize it, and they want to optimize the traffic for things that need DPUs and things that don't need DPUs. And so they can flow that through. And then once we get right on the silicon and we're actually on the ARM chip, we can start flowing it across the traffic itself. Now, the DPU is still doing its own memory and handling and all that kind of stuff. Like, but what we're doing is we're actually riding right on the NVIDIA chip at that level. So not only are we doing the load balancing of the chatbot, you know, so the web application, we're load balancing storage when that request comes in, we're load balancing the traffic into the DPUs, and then we're load balancing inside the GPUs. So we're doing that. We're, let's say, a big car company who has a lot of video feed that they're trying to build up for their model, right? So they have, oh my God, they have eight data centers where they have Velos chassis, like, you know, big things like this high, pulling in the video feeds from all the cars. Then they go back to their environment where they've got their own power station that's feeding their data center that's starting to do the model building, and they're using us to massage all that data back and forth. It sounds crazy, but the Air Force is doing one right now in Dayton at Wright-Patterson. Right, so there's a lot of these that are starting to spin out. So it's getting crazy how we're just trying to load balance this. Then we got to worry about security. So then we start to figure out how do we actually turn this into something that where you can protect these applications. So we're starting to see customers who are sort of moving along the curve, and I think the DoD is in the second to third stage of that. So the first stage is you're just playing with it. You sort of got the you know, there's a chatbot out there and people are using chatbots. The second phase is, well, we don't want you using chatbots. We're going to give you the chatbots you can use, then we're going to host them internally. That's kind of where a lot of organizations are. And where we're seeing the DoD start to move forward on this is to that third stage, where you start to develop your own applications. And so we're working with some SIs and some DoD organizations where you're starting to write your own application. There's something called Open Web UI, which is an open source chatbot. You can go download it off GitHub, and without one lick of coding, you have a chatbot that you can say, I want it to go to Olama, or I want it to go to Grok, or whatever. You can choose the model you want to talk to, right? But it's an interface that you can do. Then you can go and start coding it. And so a lot of the apps today are based on the framework that is in Open Web UI. They're just tweaking it and changing it. So F5, we have our own internal chatbot. If you're on our network or on our VPN, we can connect to it. So we can talk to things that are F5 proprietary. We can talk about customer information. It has access to our internal SharePoint environment. So we can make requests back and forth, about customer information without having to talk to ChatGPT. I use ChatGPT. I use Claude. I use Grok. Probably I've used Meta if I didn't expect to. But being able to use all those, I don't do anything that's customer related on those. If I'm going to do something customer related, I use our internal chatbot. So what we want to do then figure out how we're going to protect that. So the interesting thing now is how do you protect that, and how do you say, okay, how do we stop somebody from jailbreaking this application?
And
so that's where
that's
we start to get into
where the demo starts.
yes. See, I was talking.
This is where the demo starts.
And so the next step is, okay, now I've got this application. How do I start to protect that and stop somebody from exfiltrating data or exposing information that I don't want them to expose? And so, you guys familiar with the web app firewall? Yeah. Like it's going to stop you from doing a SQL injection, or it's going to stop somebody from doing a cross-site scripting attack on your web application or something like that. Well, we need something like that for a chatbot, right? So we came out with something that's called, I think my laptop went to sleep. There we go. Please screen work. Wasn't working before, but I got it working. Let's see.
Oh, yeah. Yeah. I also like data. I also do as well.
don't know if I've actually ever seen an A12. I've seen a bunch of SSW1s, but I don't know if I've actually physically been in beside an A12. So
The A12.
it's smaller, right?
It's not as smooth. There's like sort of little cutouts into it. It was like the prototype to this or something.
Okay, I'm going to talk. I'm going to reboot because I rebooted earlier and it worked. So okay, this is going to reboot.
So
Yeah, that's what I didn't do it if I don't want to do it. Obviously. Well, it's good dying. We had temperature for all the European countries. They don't share data.
Just 5 eyes, I think. Right?
Oh, wow.
Yeah.
This, that would be. And I don't know, it's like how pissed are we? Yeah.
Yeah, so there's my company, called Hank, and, so we just, so we're alley to here, or that, this is kind of the first show, and, we have one.
It's so new. I didn't even know. I didn't even know about it till yesterday. So there, look at the screen. Yay! Good.
Maybe you're part of it? Oh, I mean, I know, I work with TechNet. Years ago. Yeah.
Yeah. Not him directly, we're working through, branch form.
They were in
Through EMS Connect, and we were working with this.
And we had almost going with Brad, pretty well, we want to talk about their DoD mission.
Yep, we're in that mission network.
Okay.
But they're,
But
exactly to your point, it's scanning capabilities. Yeah.
but for the duty down, maybe help with our, PhD.
I was over.
Doctor.
Over 7 smiles at Captain. I'm retired.
So my little sister, she worked for the block line, and she got for home sex. So the city is career. She's amazing there. She got energy reach, so responsibility. A lot, and so I was you're gonna miss the AI demo? I'll send you, if you, did I give you that demo? Now, if you want to see a demo, we have a recording channel.
Yeah. Thanks, I don't have it.
It's okay. You ever going, JD? Yeah, okay. Oh.
Yeah, it's coming up on here, but it's not showing up. Like I can't send anything over to there.
Is it recording over there? Yeah.
Yeah.
Yeah, okay.
yeah.
So all right, awesome.
You were, you have an administrator. just-
No, it has to be a month.
Okay, got it.
I have to log in.
Oh, and it's like,
Let's just say that.
I'm sorry, folks. I did something earlier and I can't get those people.
You should have been here.
literally had it all worked out. That's what I've been doing there. Go over this, show this, show. So basically, the demo allows you to like basically our AI firewalls. We call it AI guardrails. Basically, what it does is allows you to integrate to our guardrails, and so you can take your application and either proxy it through it, or at the code level, you can actually insert in your code. So you open web UI application, you can call to us and you will validate the requests. And so we come up with a bunch of guardrails, things like PII and, the social security number and credit card number and all those kind of things. But that's fine, but it doesn't cover everything. So the demo I'm going to show you is, I've been doing a lot of vibe coding. So, and so when I send stuff on, I send a log data on and say, hey, what I used to put done was on the stack trace and have like, type it in Google and said, I got this error, and say, here's your 14 stack trace articles, go read them and figure out what you do. Well, now with vibe coding, I just copy and paste my stack trace, my error, my dump, right? All the errors are there. I send it to my chat file, and he goes and says, oh, I can update the code. Make all the code, great, go ahead and do this. But the problem with this is there's a whole bunch of information that's in that stack trace. There's the host names that I'm using. There's the ports that I'm using, the IP addresses, right? So if I'm working on a classified environment, maybe it's not like an air gap environment, but it's a classified environment, and I send that data up. Who knows who's getting it? Because every piece of data that goes into the model, even in an input request, goes into the model. So if you're using DeepSeek for this request, because a contractor who's a contractor for another contractor for a DoD project, and suddenly starts using DeepSeek, which is Chinese based, it pretends there's a potential that that data could be. So with our guardrails, we can say, I don't want any requests to include host names or ports or the source supply chain that I have in it. So don't tell them I'm using this library in Java, this version from this library, this version from that. Don't expose them. Now that's going to limit me in what I can make a request to in the chat box, but it's going to protect the application. So to stop somebody from do that, the guardrail, you say, you just literally in natural language say, don't allow those. You don't need to figure anything out. The chat, what we do is we actually run this through and model it. As the request comes in, we say, you don't want us to put host names in it. You never said that a host name is an IP address, or it could be an SVN, or it could be .local, or .com, or .io, or whatever. The model will figure those things out and will launch that traffic. Or it obfuscates it. So I'm going to redact that information and still send that up. Because the host name in and of itself isn't that important if you redact it. And that will allow you to get the answer, but not expose it. So that's what the way. Yeah. Super cool. Just unfortunately, I'm a software guy. That's a hardware problem. It's like my friend said. Probably gonna be right. Yeah. I can't help it. Yeah. That sounds good.
And for that shirt, those things are like collective items.
Oh, yeah?
We do one shirt every year. So like, people show up rock.
Oh, so how much can I get?
Yeah. Oh, no, a lot. A lot.
Thank you.
Yeah.
All right, man. See you.
Yeah.
Cheers, man. Thanks.
Thank you.
Thank you.
Chad, for the net.
What's that?
Thanks for the net.
I can't believe I broke my